You tap your phone, you pay for chai, 20 rupees gone in a second, and you never think about it again. But in that 1 second, 4 companies you've never thought about just agreed on something perfectly, down to the rupee. This is UPI, and this is what's actually inside it. Rewind to 2015. You want to send 500 rupees to a friend at another bank. Here's what that took. Open your bank's app to find add beneficiary. Type their account number, all of it. Then the IFSC code. Then wait. Maybe for a cooling period, maybe for the next settlement batch. No nights, no Sundays. Or you just handed them cash, which is what most of the country did anyway. There were faster rails underneath. MPS was genuinely real time, built by the same people who'd go on to build UPI. But every bank had its own app, its own flow, and you still needed those account numbers. So here's the thing nobody said out loud. India didn't need better banking apps. It needed one shared language for money, a protocol every app and every bank could speak. That's what UPI set out to be. Before we open it up, one number, so this isn't a toy. In 2025, UPI processed 228 billion payments. That's about 698 million a day, every day. It's the largest real-time payment system on earth, and it isn't close. And here's what matters for the engineering. Each of those payments isn't one message. It's 6 to 10, bouncing between apps, banks, and the switch in the middle. So on a festival night, we're moving hundreds of thousands of messages a second. So what's actually hard here? It isn't speed. Speed is the easy part. A payment isn't one thing happening. It's two. Money has to leave your account at your bank and arrive in their account at a completely different bank. Two companies, two separate ledgers. Neither one can see inside the other. And both of those things have to be true together, or neither can be true at all. Now do that in under 2 seconds. Do it when the network drops halfway. And do it a few billion times a month without getting a single rupee wrong. That's the problem. Let's meet everyone involved, because it's more players than you'd think. There's your app, Google Pay, PhonePe, Paytm, whatever's on your phone. Then your bank, the one actually holding your money. On the other side, the same pair, their app and their bank. And sitting dead center, wiring all of them together, NPCI. The National Payments Corporation. They run the switch. Picture air traffic control for money. It doesn't hold a single rupee itself. It just routes and tracks every payment moving between banks. Here's the clever part. The app that gives you the experience and the bank that holds your money are completely separate. Your cash can sit at one bank while you pay through an app run by another. That split is exactly why the apps got so good. They compete on the experience and leave the banks to guard the money. Now the single most elegant idea in the whole thing, the address. When you pay someone, you don't type an account number, you type a name. Chaiwala at Paytm, or just their phone number. That little handle is a VPA, a virtual payment address, and it works like a web address does for a website. You type a name and something quietly translates it into the real numbered address underneath. Same here. Chaiwala at Paytm gets resolved behind the scenes into a real bank account you never see. Which means you can hand your UPI ID out freely. Print it on a wall, stick it on a shop counter. Your actual account number never leaves your bank. And there are 5 ways to point at a payment, but they all funnel down to the exact same request. Okay, let's build the whole map, one layer at a time. Top layer, your phone. The app and one small piece tucked inside it we'll come back to. Next layer down, the PSP, the bank infrastructure your app plugs into, the on-ramp to the network. Center, NPCI. The switch that routes everything, a directory that turns phone numbers into accounts, and the engine that settles up between banks at the end of the day. Bottom layer, the banks. And inside each bank, two things: the core banking system, the actual ledger where your balance lives, and a small security module we'll get to in a minute. Now look at where things live. Your identity sits up at the app layer. Your balance only ever lives at the bank. And the state of each payment lives at the switch. No single box holds all of it. That's on purpose. Every payment in India legally needs two-factor authentication. Two independent proofs it's really you. UPI pulls that off without you barely noticing. Here's how. Factor 1 is your device. When you first set up UPI, the app quietly sends a text from your phone. Because that text can only come from your SIM, it binds your account to this exact handset. A stolen UPI ID is useless without it. Factor 2 is your PIN. Now watch what they do with it. When you type your UPI PIN, you're not typing it into Google Pay or PhonePe. You're typing into a small secure component. NPCI drops inside every UPI app. The app wrapped around it never sees your digits. Your PIN leaves the phone already scrambled, and it only gets unscrambled in one place on earth. A tamper-proof chip at your bank. Not the app maker, not even NPCI. Only your bank can check your PIN. Now the main event, one payment, 500 rupees. Start to finish, watch every step. Step 1. You enter Chaiwala at Paytm. Before a single rupee moves, the system resolves that name and shows you who's really on the other end. Paying Ramesh K, that's your first fraud check. Wrong name? Stop right there. Step 2. You approve and enter your PIN in that secure keypad from a minute ago. Step 3. Your app sends the payment to the switch, stamped with one unique transaction ID. Remember this ID. It's the hero of the second half of this video. Step 4. The switch, goes to your bank. Check the PIN. Check the balance. Take out 500. Done. The money has now left. Step 5. The credit. Only now does the switch turn to their bank and say, put 500 into Ramesh's account. Done. Step 6. Confirmation flies back. Your phone says success. Ramesh's phone buzzes. 2 seconds, end to end. But wait, what if step 5 never answers? You've been debited and Ramesh got nothing. Hold that thought. So here's the problem, stated plainly. Two rights. Two banks that can't see each other. No shared database to lock them together the way you could. Inside one company. Either both of them happen or the money is wrong. Everything UPI does from here exists to make sure that never happens. The obvious fix is something computer science already has. It's called two-phase commit. Both sides prepare, then both sides commit together in lockstep. Inside one company's database, it works beautifully. Across banks, it falls apart. Because two-phase commit means one bank has to freeze that row, lock your account, or worse, a busy merchant's account, and hold it waiting. While it asks the other side, ready? 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 Now picture one side crashing mid-conversation. The other is stuck holding a lock on a live account and nobody else can touch it. Do that across 300 banks, some running software older than the engineers maintaining it, at 30,000 payments a second, and the whole thing seizes. The slowest bank freezes everyone. So UPI throws two-phase commit out and does something smarter. Instead of locking two banks together, UPI does the steps one after another and picks the order very deliberately. Debit first, credit second, always. Why that order? Picture the alternative. If you credited Ramesh first and then your debit failed, you've handed him money you never collected. And clawing that back out of an account he might have already spent is a nightmare. Debit first flips the risk. If the debit works and the credit fails, the worst case is your 500 sitting in limbo for a bit. And that's fixable. You just give it back. Refund the payer, no other bank's cooperation required. No locks, no lawyers. That refund has a name, a compensating transaction. Instead of trying to prevent every failure, you let each step happen, and if the next one fails, you undo the last one. It's the difference between two people freezing with pens over a ledger, waiting for each other, and just writing in pencil with an eraser handy. Remember the transaction ID from the money shot? Here's where it earns its keep. Real networks lose messages constantly, so the switch often has to retry, send the same request again, in case the first got lost. But retrying a payment is terrifying. What if the first one actually worked and now you debit twice? The ID is what saves you. Every party, the switch, your bank, their bank, treats it like a fingerprint. Do the operation once, record the result under that ID. See the same ID again? Don't redo it, just hand back the answer you already have. That property has a name you'll hear all season: Idempotency. A retry safe right. Do it twice. It still only counts once. Panic tap pay 5 times and the network might fire 5 messages. But you get charged exactly once. But there's one case even the ID can't answer on its own: the timeout. Your debit worked, the switch asks their bank to credit, and here's nothing back. Not a yes, not a no. Silence. Maybe the credit happened and the reply got lost. Maybe it didn't. The switch genuinely does not know. This is the ugly middle of every payment system, and UPI's rule for it is strict. No payment is ever allowed to stay unknown. So the switch asks, using that same ID, what actually happened to this one? Again and again if it has to. If the credit truly failed, it auto reverses, your money comes back on a deadline the regulator enforces. Miss that deadline and the bank literally owes you 100 rupees a day. And every night, all three, your bank, their bank, the switch, line up their records and hunt for any mismatch. That reconciliation is the boring, relentless machinery that makes the money is never lost actually true. Now I'm going to break something you thought you understood. Ramesh's phone buzzed, received 500 rupees. So 500 rupees moved from your bank to his. Right then? No, it didn't. Here's what actually happened. Your bank lowered your balance in its own books. Their bank raised Ramesh's balance in its own books. Both banks just updated their own ledgers. No real money crossed between the two banks in that moment. Instead, their bank is now quietly owed 500 by yours. An IOU. And UPI settles all those IOUs later, a few times a day in one big batch. Watch. Bank A owes B 100 crore, B owes A 80, A owes C 50. Instead of moving all of it, UPI cancels it down to who owes what on net. And only the small leftover actually moves in real money at the Reserve Bank. UPI feels instant precisely because the real money barely moves at all. So far, we've seen how UPI stays correct. Now the harder half. How it does this at the scale of a billion people. Let's put real numbers on it. Around 700 million payments a day. Divide it out and that's roughly 8,000 every second, on an average afternoon. But traffic isn't flat. Salary day, a festival, a big sale, and it spikes to tens of thousands a second. And remember, each payment isn't one message. It's 6 to 10, bouncing between apps, banks, and the switch. So the switch is really juggling hundreds of thousands of messages a second. Everyone tracked, none ever dropped. That pressure is what shapes everything next. Here's the first move. That switch in the middle was never one machine. No single box could take that flood. It's a fleet. Requests hit a load balancer, which spreads them across a whole row of identical routers. And the trick that makes it work, those routers are stateless. Each holds nothing of its own. No balances, no memory of the last request. So any router can handle any payment, and if one dies mid-flight, another picks up without missing a beat. Need more capacity for Diwali? You don't rebuild anything. you add more routers to the row. That's what scales horizontally actually means. Growth is addition, not surgery. But if the routers hold nothing, where does the state of every in-flight payment live? In a store behind them. And that store faces the same flood. You can't put a billion payments a day in one database. It would melt. So you split it. This is sharding. Take the transaction ID, run it through a hash, and that decides which shard, which slice of the database owns that payment. One lands on shard 3, the next on shard 9, spread evenly, no single piece ever the hot one. The phone number directory is split the same way. And the banks shard their own ledgers by account number. The whole system's secret is that nothing important lives in one place everything has to fight over. Sharding spreads the load. But what if a shard's machine dies with live payments on it? So every shard is replicated, copied across machines, across data centers. So a failure loses a copy, never the payment. Which brings up the deepest trade-off in the whole system. When you are spread across machines that can lose contact with each other, you can't have everything. You pick. UPI's choice. Stay available and fast for you always. And accept that between banks, the books only need to balance eventually, fixed by those reversals and reconciliation from earlier. It feels instant and perfect. Underneath, it's availability first, with corrections, not one giant lock everyone waits on. Two more pieces keep this fast and safe. First, catching. Some answers get asked constantly. Resolving a name to an account, checking a payment's status. Instead of hitting the database every time, the hot answers sit in a fast cache in front of it, so the common case never touches heavy storage. Second, the clever defensive one. The switch doesn't fully trust any bank. It watches each bank's response times. And if one starts slowing or failing, a circuit breaker trips. The switch stops sending it traffic for a moment, so one sick bank can't drag everyone down. Add per bank rate limits and no single player, a buggy app, an overloaded bank, can flood the network and starve the rest. Put it together and you get a system built for its worst day, not its average one. The whole thing runs active. Several data centers all leave at once. So losing one costs capacity, not the country's payments. Festival nights are planned like a rocket launch. Extra headroom provisioned, the smallest payments pushed onto UPI Lite, so they skip the banks entirely. And if something still strains, it degrades gracefully instead of falling over. And every bank is scored on its P99, the slowest one payment in 100, published in public. Because in a network this federated, measurement is the only thing that keeps 300 banks honest. The slowest bank sets the ceiling, so everyone can see exactly who it is. So let's go back to that chai. In 2015, sending 500 rupees across banks meant a form, a code, and a waiting batch. Today, it's one scan. And underneath that scan is everything we just walked through. A debit-first saga, an idempotent transaction ID, IOS netted at the Reserve Bank, and a fleet of stateless machines sharded across data centers, running 698 million times a day. More real-time payments than the rest of the world combined. The lesson isn't India built a slick payments app. It's that the right few ideas, a name instead of an account number, a neutral switch in the middle, undo instead of locks, and nothing important living in one place, turned a mess of separate banks into one system. Getting the money right in 2 seconds is one hard problem. Getting it right for a million people the instant the market opens, that's a different one. That's Zerodha. Next time.